Now that we have seen the assumptions of the neural network, now it's time to look on an important function or important method or aspects of the neural network, that is a training of neural network. We are telling that we have to train the neural network to perform a task. When it comes to any model, say it a machine learning model, either it may be a logistic regression model or a linear model, any model like SVM, etc., we have certain things or certain parameters to get trained, right? So similarly, when it comes to neural network, we require rigorous training. But what does it mean to train a neural network, right? So what are all the parameters which the neural network learns during the training? So what does exactly training of a neural network mean? Like what does the network learns during the process of training? And what are all the hyperparameters which you as we design the network, what are all the hyperparameters which we need to specify beforehand? So we'll study all these things in this session. So the training of the neural network exactly deals with how a network actually learns the patterns present in the data. So now just recall the models such as linear regression or a logistic regression or SVM, etc., are trained on the coefficients, right? There will be coefficients associated with the x term, right? Say m, we can call it as m, associated with each and every x term. So and we have to the model has to learn those coefficient, right? The training task is to find the optimal values of those coefficients to minimize the cost function. There will be a cost function, right? Y equals to mx plus c kind of thing. So that will be the intention or the training of a normal machine learning model will look like. Similarly, what does it comes to the neural network? So when it comes to neural network, they are no different than these linear regression or logistic regression models. But instead of a network or a training, we instead of we focusing on the coefficients, we have terms called as weights and biases. In the previous sessions or in the previous explanations, when I try to explain the assumptions as well, we have come across the term called as weights and biases, right? We have said that each and every interconnection has its own weight associated with it, and each neuron has its own bias associated with it. So these are the learning parameters. So the network at the end of the day has to learn what are all the weights it has and what is the bias for a particular neuron. So when the network is familiar about these weights and biases, then we can say that the network is trained on the data. So when it comes to weights, biases, and hyperparameters, so during the training, the neural network learning algorithm fits various models of the training data and select the best model for the production. The learning algorithm is trained with a fixed set of hyperparameters. So what are hyperparameters? These are the deciding parameters. See, when it comes to a game of cricket, what would be the hyperparameter, right? We will have to see at the pitch, right? What is the condition of the pitch, whether it is a dry pitch, whether it is a hard pitch, or it is a wet pitch, whether we can do a bowling for the bowling at first, or we have to go with the batting first. So all those things would be hyper parameter when it comes to cricket, right? Similarly, we have certain hyper parameters which we have to decide when it comes to design the structure of the neural network. So I will discuss the hyperparameters in the further below session. So yeah, so a neural network would be having a fixed set of hyperparameters, and it is trained on the weights and biases, which are the parameters of the network. So here you can clearly see there is a clear differentiation between what is hyperparameter and a parameter. So the parameters are the things or the values which the network has to learn. When it comes to parameters of the network, then it is weights and biases. But when it comes to hyperparameter, that would be the decision parameters, or the beforehand when we come to design a neural network. So let's now have a look at those hyperparameters. I have listed very few over here, but we can have a detailed discussion as well. So the very first hyperparameter would be the number of neurons in the input and the output layer. Yes, that number, we cannot just have a core like linear relationship, but we can have an assumption, or we can make a statement that yes, learning of a neural network purely depends on the number of neurons in the input and the output layer. Can we say more the number of neurons in the network is more that it will lead to better learning? No, no, no. It is not the case. It is a hyperparameter. Yeah, that is the decision we have to make. Either choosing large number of neurons will make our task easy, or choosing very few number of neurons will make our task easy. That is the decision parameter. We have to make a trial and error. We have to decide those things when it comes to designing the input and output layers, and deciding the number of neurons in the input and output layers. But one thing we can clearly say that the number of the number of neurons in the input layer may have a correlation with the number of input signals, right? How many number of input signals we have, or how many different kind of inputs we have at the input. We can have some correlation with that. That is about the first hyperparameter. Then the hyperparameter would be the activation function. Yes, this is very important, right? What kind of activation function we have to choose? Whether our network is going to have a softmax function as an output layer, or a sigmoid function as an output layer. Yeah, when it comes to a multi-class classification, or a multi-class classification problem, then we will be having a softmax function, right? That will be an activation function there. But when it comes to a decision making, or a single decision making problem, that is a regression problem, then we would not be choosing that softmax function as an activation function, right? So that would be the decision hyperparameter which we encounter before in hand while we have to design a neural network. Then other parameter hyperparameter would be the number of layers as well. So how many number of layers should be fitting in between the input and output layer? We have termed it as hidden layers, right? So how many number of hidden layers that can be, that we have to choose for our network? So deciding those things would be the hyperparameters for the given neural network. But the things which the neural network learns, or the learning or the training happens only on the weights and biases. So these are the decision taking parameters, but these are the parameters on which the neural networks actually learn. So we have these clear things, right? We have parameters, weights and biases. We have hyperparameters, that is number of neurons, activation functions, number of layers, etc. In the next session, we will try to have some common notation, or a general nomenclature, what we can call, to identify each and every term. So how to identify weight, how to identify an activation function, how to identify a layer. We will have certain notations or symbolic representation for each and everything in the upcoming session.